Bismillahirrahmanirrahim. In chapter 6 fluid mechanics, we are going to do the assignment 6.4 today. In assignment 6.4, the statement is, if the speed of air across the top and bottom of an aeroplane's wing is 450 meter per second and 410 meter per second respectively, calculate the lift on the wings. If the wing is 15 meter long and 3 meter wide, density of air is 1.29 kilogram per meter cube. Here we have given again that there is an aeroplane wing in which the velocity at the top is given, that is 450 meter per second, and at the bottom is 410 meter per second. That means the velocity at upper side is greater as compared to that of lower side. We have to calculate the lift on wings. If the wing is 15 meter long, length of wing is 15 meter and its width is 3 meter, and also it is given that the density of air is 1.29 kilogram per meter cube. So start with the given data. The speed of air at top wing is equals to V2 is equals to 450 meter per second. Speed of air at the bottom wing is equals to 410 meter per second. Length of wing is equals to 15 meter. Width of wing is equals to 3 meters. And density of air is equals to 1.29 kilogram per meter cube. We have to find the lift on the wing. That means we have to find F1 minus F2. What is F1 minus F2? As in the given data, we have seen that the velocity at upper side of wing is 450 meter per second. That means the air is moving faster on top of the wing as compared to that of the bottom of the wing. Now, as you know that as speed increases, pressure decreases. That means the pressure on the wing from upper side is lower as compared to that from the lower side. So as a result, the force acting on the wing from upper side will be lower as compared to the force acting on the wing from lower side. As the force acting in the upward direction is greater as compared to that in the bottom direction or downward direction, so the aeroplane will be lifted upwardly. So we have to find the difference between F1, which is acting in the upward direction, minus F2, which is acting in the downward direction, because it will be equal to the lift in the aeroplane. For this, we will use the formula and that is from Bernoulli's equation, which states that P1 minus P2 is equals to half rho V2 square minus V1 square plus rho G H2 minus H1. Basically, we have to find F1 minus F2, but in this formula, we have P1 minus P2. So now we have to relate pressure with force. We know that pressure is equals to force per unit area, which can be rearranged as pressure into area is equals to F. That means we will find the value of pressure difference from Bernoulli's equation and we will insert it in this relation F is equals to PA to obtain the difference between the forces, which will be the uplift in the wing. So the final formula that we will use will be A times P1 minus P2. We will find the pressure difference from this equation and then we will insert it here. So we will get the result F1 minus F2. In the solution, we will apply the Bernoulli's equation. P1 minus P2 is equals to half rho V2 square minus V1 square plus rho G H2 minus H1. Here you can see the factor H2 minus H1. It is basically the distance of top of the wing from the ground and bottom of the wing from the ground. This difference is very much less, so we can neglect it, and hence this part of the equation will become equals to 0. So the remaining equation, in the remaining equation we will put the values. P1 minus P2 will be equals to half. Value of rho is 1.29, value of V2 is 450, value of V1 is 410. Calculating the result, we will have the value of P1 minus P2 is equals to 22188 pascals. As I have already told that lift is basically equals to F1 minus F2. That is equals to area times pressure difference. Area here will be equals to length into width. Length of wing is 15 and its width is 3. So 15 multiplied by 3 multiplied by the pressure difference, which is 22188. Multiplying all these value, we will have the value of lift is equals to 998460 newtons. You can convert or write it in scientific notation as 9.98 into 10 raised to power 5 newtons. Numerical number 10 is similar to that of assignment 6.4, the statement of which is if the speed of air across the top and bottom of small aeroplane's wing is 30 meter per second and 20 meter per second respectively, calculate the pressure difference between the top and bottom of wing if rho is equals to 1.29 kilogram per meter cube for air. So in the last question the data was similar, but we had to find the lift, which was difference in the forces, for which we firstly determined the pressure difference. In this question we just have to determine the pressure difference. So according to the given data, speed of air at the top wing is v2, which is 30 meter per second, at bottom wing is v1, which is 20 meter per second, and density of air is 1.29 kilogram per meter cube. We have to find the pressure difference between the top and bottom of the wing, which can be represented by P1 minus P2. Formula which we will use will be in accordance with Bernoulli's equation, that is P1 minus P2 is equals to 1 by 2 rho V2 square minus V1 square plus rho G H2 minus H1. In solution, we know that there is not much difference between the top and bottom surface of the wings. So H2 minus H1 is negligible, so it will be considered as 0. Putting the values of V1, V2 and H2 minus H1 is equals to 0, we will get the result of pressure difference as 332.5 Pascal.